It's a pleasure to be here. Thanks for inviting me, and it's also great to be speaking at the same meetup as Stefan Tilkov, since I've followed his work for quite a long time. So let's get started. I'm just sharing my screen. So let's give it a couple seconds. So you should be seeing my screen now, the slides. All right. So as Oliver was saying, I'm going to talk about this idea of team cognitive load and what that is and what is the meaning in terms of when we're talking about architectural styles and things like monolith versus microservices. Are there other questions that we should be asking besides kind of that architectural decision? So I'm Manuel Pais. I'm one of the authors of the book Team Topologies. I'm an independent consultant. I've had a number of different roles throughout my career, starting as developer. So I have a background in computer science, and also a number of years doing consulting around DevOps, continuous delivery. And that's when me and Matthew Skelton, the other author of the book Team Topologies that you see here, the cover of the book came out about a year ago on IT Revolution Press. We started seeing a lot of in many organizations that we work with, there were issues around communication or lack of communication between teams, lack of clear kind of understanding of what are the responsibilities of different teams. In particular, also in terms of the larger software systems and which teams are responsible for which parts, and seeing kind of orphan parts of the systems as well. And so our work has focused a lot on what are some useful patterns for teams to make it clear what are different responsibilities, different purposes of different teams, and when should they interact. When is it necessary, or when should they be interacting, and when they shouldn't. Today I'm going to talk, first of all, explain a little bit what is team cognitive load, what is the team first approach that we talk about in the book. We're going to look at the case study, and then some ideas on how to get started. So team cognitive load is an idea that I would say is complementary to the aspects of what is the right architecture for our systems. So when we're seeing kind of monolith versus microservices, there's almost sometimes feels a little bit like this, right? Almost a kind of fight between the two sides. And there's over the years there's some sort of back and forth, whereas you start having some people saying, well, actually we went to microservices, but monoliths, some sort of controlled monolith is actually better. At the end, we realized that, and vice versa. So some people will say, well, start with the monolith and extract microservices as you kind of understand more about what exactly should be the microservices. You understand better what are different parts of your system that are aligned to different business value streams and offerings. So that's where you should be splitting. And so other people who are in this meetup as well, Stefan, so he can correct me if I'm saying this wrong, but I think in some of your talks you said, don't start with a monolith when your goal is a microservices architecture. So learn as you go, improve and make adjustments as you learn more. But if that's your goal, then start with that sort of architecture. And then other people, like Simon Brown, said also, if you can't build a monolith, what makes you think microservices are the answer? So if you're starting out looking at this idea of microservices, what are the benefits? Should we go for this approach or not? If you look at these different kind of opinions, which all make sense, you get to this stage where a little bit, what the hell should we be doing, right? Where should we focus? And so I think all of those opinions make sense, but perhaps there's something else we should be looking at as well. And that's this idea of cognitive load, that there is a finite capacity that individuals and teams have in terms of understanding the software that they're responsible for. So Daniel North has also talked about this, and James Lewis from ThoughtWorks as well. And they're talking about the idea that, well, if we're looking at the size of software, it should be something that fits in our head. Or if we're looking at the size of microservice, it should be something that fits in our head, in a sense that we can have an overall understanding of what this microservice or this piece of software is doing, so that we can actually evolve it in a sustainable way. So if we take that at the team level, then we could be talking about software that fits in our heads. And so perhaps that's a starting point that we should be looking at. How do we split this large monolith that we know becomes hard to change? We have a lot of dependencies between different teams, and we know that's not ideal if we want to be able to evolve our offerings and our products more quickly. We need to move away from that. But perhaps we should start with what is the size that makes sense for a given team, right? And often that might mean that at some point we decide that microservices is a good approach, but it should be in line with the idea that we have been able to split the system and the different kind of business streams, if you like, in a way that makes sense, that we have teams that are able to be more autonomous and understand fully the software that they're responsible for, so they can evolve it in a more efficient way, a faster way. So when this doesn't happen, when there's not a clear kind of focus on does the team have the right skill set, the right knowledge around this part of the software to be able to understand and evolve it sustainably, then there are a number of metrics that we have known today that are meaningful, especially from the work of Dr. Nicole Forsgren and Jess Humboldt, Jean Kim. So I would imagine many of you are familiar with this book, Accelerate, and the State of DevOps reports that come out every year. So this research-based evidence that there are some key metrics for software delivery teams around lead time, deployment frequency, mean time to restore and change fail percentage. Effectively, this gives an idea of speed, how fast are we able to make changes, but also the operability of the software that we're responsible for and the quality, right? So if the team, again, doesn't have enough or the size of the software or the complexity of the software they're responsible for exceeds their capacity to fully understand it, then likely all of these key metrics are going to be negatively affected, right? We won't be able to deliver as frequently. When there are problems with the software, it's probably going to take us longer to diagnose and to identify what is the problem and find a solution, because we don't fully grasp what is going on, right, in the whole software that we're responsible for. So in a way, it's software that is too big for our heads or too big for the team works against this idea of being agile and being able to deliver value and adapt to the needs of the actual customers quickly. So cognitive load is actually has a specific definition from John Sweller. He's a psychologist, so this is from back in the 80s. So at an individual level is the total amount of mental effort being used in the working memory. And kind of the interesting aspect of cognitive load is that we can actually break it down into 3 different types of cognitive load. There's intrinsic cognitive load, so which is related to everything, kind of the skills that we need to do our day-to-day job. So if we're working on a Java-based system, and we don't know or we don't remember how you create classes, methods, and or unit tests or whatever it is, then that's going to be taking up some of our working memory, right? So that's going to increase our cognitive load if we don't have kind of the skill set that we need to do our day-to-day job, or we don't have enough experience. There's another type of cognitive load which is extraneous. So this relates effectively to all the kind of, in a way, superfluous tasks that we need to execute, but are necessary to deliver our work. So if we need to think about how do I deploy the application, or how do I access the test environment, or how do I clean up the test database, or any kind of aspects related kind of with the mechanics of deploying our work and changes to our services, it's all this sort of extraneous cognitive load. We're not directly adding value, but these are things we need to do to get the value, right, to the customers and to the organization. And finally, the third type of cognitive load is germane. So this is everything that is related directly to the business domain. So if we're working on some sort of banking application, then we probably need to know a lot about that domain to be effective. We need to know how bank transfers work. We need to know how accounts work, and all sorts of things. So if you look at it from this perspective, or say, well, there's intrinsic kind of the skills we need to do our day-to-day work. There's extraneous, which are all kind of the mechanisms that are needed to deliver and run our services. And the germane side, which is everything related to the actual domain, to the problems we're trying to solve for our customers, or the value we're trying to provide. Then what we would like is to, knowing there's a kind of finite amount of cognitive capacity, is to focus most of it on the germane side, right? So we want to minimize intrinsic and extraneous cognitive load. And so obviously there are a number of techniques we know that are useful. For example, in terms of intrinsic cognitive load, we can do kind of classical training, we can do pair programming or mob programming, we can do mentoring. We can have communities of practice that help people learn and improve. So that's all useful. But we don't have a lot of kind of concrete ways where we're minimizing explicitly the extraneous cognitive load. Yes, we have automation, obviously, that helps, but we're not often being explicit enough in how we're going to address this sort of extraneous cognitive load. There's a lot of work by Joe Pearce that is quite interesting around cognitive load and this idea of hacking your head. So this is just a reference if you want to dig deeper into that. Going back to kind of the idea of the systems and the architecture, and the importance of thinking about team cognitive load, effectively what we want to do is limit the size of the software or products to the cognitive load that the team can handle, right? So this idea that we need to have the team to be responsible for software that fits in their heads. And so team cognitive load can be and should be a key consideration for organizational decisions, both in terms of how do we set up our teams and what kind of system architecture we should have, so that we're allocating parts of the system in a way that meets the cognitive capacity of teams, and understanding that it's not just about understanding the software itself, what it does, but also understanding how do I release the software, how do I test the software, how do I deploy, etc. There are other decisions that we can, if we look at it from the lens of cognitive load, we might get to different decisions in terms of what is the team composition. Should we hire experts in some domains, or should we focus on upskilling the team, and so on. So there's also the idea of having this team first approach that we talk in the book, Team Topologies. The idea that the team is actually the unit of delivery that we should be looking at, right? We shouldn't rely on individual heroics and kind of individual experts to be able to do certain kinds of work. Ideally, we're focusing on teams, making sure that each team has the capacity to own and evolve their part of the system. So this team first approach to digital products. So when we talk about a team, we're specifically saying a group of usually between 5 and 9 people, because of issues of not just kind of the coordination inside the team, but actually the trust that we can build inside the team. So if you're familiar with the work of Robin Dunbar around Dunbar's numbers, so there he talks about kind of these boundaries of trust, if you like, where up to about 7 plus minus 2 people is where we can have deep trust, and so the team will be able to, if the team is stable and long-lived and has a clear purpose, they will be able to achieve higher performance. Sometimes you can go up to 15, but that requires already a stable team for quite a long period of time and high maturity kind of environment to achieve that. Usually 7 plus minus 2. So these are the teams we're talking about: long-lived, stable teams. Which doesn't mean that we don't make any changes to the team. Obviously, people leave and people come, but we keep this team as an entity stable and long-lived. So when we want to achieve sort of high-performing teams that are as autonomous as possible and can deliver independently, then we need to be very careful about choosing understanding what are the different streams of work in the organization and that we're trying to address with these teams, and the domain boundaries. So something that perhaps you've seen and that we hear on a regular basis is that we might decide to have a nice microservice architecture. We have perhaps different teams aligned to the different microservices, right? So this sort of Conway's law approach, where we make the structure of the system in line with the structure of the teams. But even then, if we didn't really identify our streams of work well and understand what are the different value streams that make sense, then we still might end up with this situation where we want to deliver one feature, or we want to make some changes to a user journey, and we end up having to involve many different teams responsible for many different microservices. So that might happen when we haven't really identified what are the streams that evolve more independently. And so we want to align the teams not just with microservices, but with these different streams of work. So what are these streams? This usually can be a specific service that we provide to our customers. For large products, it might be a set of features that we identify within the large product. It might be, in some cases, we have different user personas, and so it makes sense to align teams to these different streams, where perhaps we have enterprise customers and they have very different needs and experience from an individual customer. We might have some compliance regulations that we have to follow, where that's actually a stream of work by itself. And sometimes even different markets or geographies might mean that we actually make sense, even though the functionality might be similar, it actually makes sense to have different teams working and very closely aligned to these different markets. And so, it can be other things, but thinking about what are the streams of work, what is the kind of a continuous flow of work that is more or less independent from other flows of work. And so to identify this, we can use things like domain-driven design, of course, to identify what are our core domains and our supporting domains, etc. We also have a very lightweight technique called independent service heuristics. So it's just a joke. We call it DDD Light. So there is a GitHub repository if you want to have a look at that. So actually, under github.com/team topologies, there are a number of repositories with some of these techniques and templates around the ideas of team topologies. These heuristics are essentially just a set of questions for us to think about. If we have a candidate stream, we think that this is a kind of independent stream. Let's try to answer these questions and see if the answer shows us that yes, it seems to be more or less an independent service, or it could be or not. So it's just a lightweight way to kind of try to have a quick validation if does this candidate stream seem to make sense or not. so that, again, at the end of this sort of analysis, or if we're using domain-driven design, we can identify what are those kind of different streams that make sense to align the teams with. Other aspects that we need to look at when we're trying to make sure that the cognitive load of the team is not exceeded is not just on one side is the size of the software and the complexity of the software they're responsible for, but it's also thinking about what is the developer experience for those teams. So if we have, for example, sort of platform and a platform approach where we're trying to provide some useful services to our development teams, it's not just about having some set of shared services that we can provide to them. It's actually thinking about the experience of using them, because if we have this sort of platform where we're imposing some sort of standard tooling and standard approaches to teams, but they don't actually meet their needs, or they're difficult to use, or the API is confusing, or this service is often not available or under maintenance, then we're actually causing perhaps more problems to those software delivery teams than what we're helping with, then we're helping them, right? We're actually increasing the cognitive load if we're forcing them to use some sort of platform or tooling that doesn't meet their needs, that actually causes them to have to invest time to understand it. So developer experience focus is key for keeping cognitive load under control for those teams. And obviously, when we have really powerful and tooling and platform services that are really adequate for the needs of the delivery teams, then that actually helps reduce how much they have to worry about, helps reduce cognitive load on the extraneous side, especially. So that will help the team have more space for the germane aspects, the business aspects. Similarly, we also want to focus on the operator experience. So regardless if this the operational responsibility lies within this sort of build and run teams, or it's more traditional ops teams, whatever kind of organization we have, we should be focusing also on the operational, on the experience for the operators. Make sure we have adequate logging, monitoring, ways of debugging problems in production, and so on. As I was saying, one of the keys that we found to keep cognitive load under control for delivery teams is this idea of the platform. But this kind of modern way of looking at the platform as a product, where we're actually, the teams responsible for developing the platform should be thinking about it as internal product, yes, but we still need to focus on, understand who are our internal customers, understand that there are different needs that different teams might have. Not every team is coming and starting from the same point, right, in terms of their maturity, their experience with different parts of the software delivery lifecycle. So when we think about the platform as a product that drives good behaviors in terms of not just building stuff and technology, but actually focusing on, are we addressing the problems of the software delivery teams, the things that are causing them to kind of have too much cognitive load. So in team topologies, we identified 4 fundamental types of teams. The stream-aligned team is the sort of product team, if you like. Now that you've seen what are the streams that we're talking about, then obviously the idea is that we align the teams to those so that they're working on this continuous flow that is mostly independent from other flows of work. We have enabling teams that are more focused on helping bring the knowledge around certain domains to the different teams. Some sort of, if you like to look at it, some sort of evangelizing or internal consulting to the teams, so that we help them upskill and, again, address cognitive load, intrinsic and extraneous cognitive load, by having experts that can help us understand, what is the good way to, the good practices around different domains, security, continuous delivery, observability, whatever it might be. We have complicated subsystem teams. I'm not going to talk too much today, but sometimes we do need, because of cognitive load, to have a team dedicated to some kind of very complicated part of the system. And the platform teams, in the sense that I was talking about, this modern platform as a product. So the way we look at this in terms of flow is that we expect most teams to be stream-aligned, right? So once we have that identification of what are the actual streams of work that are more or less independent, then we can align the teams, those stream-aligned teams, with that. So you can think about this as build and run teams or product teams. There are different terminology. So we expect these teams to have end-to-end responsibility for their service. Might be microservices, obviously, but the key is that they have this end-to-end responsibility, and then we have the platform to help those teams do perform certain activities and do certain parts of the life cycle in a much more easy way. And then we have different interactions between teams, so that we're not just saying this is the type of team that we have, but actually when are these teams supposed to collaborate, or when should they be facilitating, helping teams gain some knowledge, or when is it an X as a service sort of interaction, where we say we have these services perhaps in the platform, usually that we're providing to the stream-aligned teams, and we expect them to be stable, to be easy to use, to have a good developer experience. And so we're not expecting to have to change them. They're kind of stable, very, very much like we consume services from AWS or Google Cloud or any other kind of SaaS provider. So what we're trying to achieve with these types of teams, interaction modes, and the evolution of these interactions is to achieve rapid flow of change. And so the starting point is those stream-aligned teams that have end-to-end responsibility. And we also expect them to be able to get rapid feedback from the running systems. That's why we want this build and run type of teams, right? So again, we come back to the idea of that each service should be fully owned by a team with sufficient cognitive capacity to build and test and release and operate it. So it's not just about understanding the software itself, but understanding how do we do these things. This sort of, we often hear being called product team. So we call them stream-aligned team, but it's effectively the same thing, this end-to-end ownership and being able to get the information and feedback from the live service into the next iterations of the product or service. Very briefly, I'll go through this case study. Before I do that, Dr. Naomi Stanford, she's an expert in organization design. She has written several books. So that's one of the key references that we have in team topologies. She talks about this idea of organizations that want to adapt, to be adaptive and react quickly to changes in market and technology, etc. They need to do this sort of environmental scanning. So from a software system perspective, we need to be aware of the evolution of the systems, not just the monolith and identifying that we have a monolith and these are the kind of the dependencies and problems we have to address in the monolith, but also even if we have a microservices architecture, we should do this sort of ongoing scanning of is this actually helping us achieve more autonomy in the teams? Are we able to deliver more frequently and get value to the customers faster? Or do we have this microservice architecture, but at the end of the day, we haven't actually improved on those things? Maybe because we have this sort of distributed monolith, or we haven't aligned the microservices with the actual streams of work that are happening in the business. So the case study reflects this idea. So in this organization, they're a large retailer around the world. This idea of kind of ongoing analysis and scanning of, are we actually moving the right direction or not? So I'll tell you a little bit more about this. So this case study is also in the book. So this very much enterprise organization, quite large. They're with their IT department, very much process focused, and any kind of release would typically take several months, right? And so they had a need to address some emerging markets. So they wanted to enter these new markets, and they said, we can't, wait 6 months to have a first release. And so they said, okay, we'll kind of do a sort of pilot. That's often the magic word. Kind of pilot. We'll do something different. We'll create a small team, a cross-functional team with business owners directly involved, not just kind of a proxy, but the actual people who are going to make the business decisions are part of the team, and they'll have full autonomy to decide to use, public cloud. They can use any kind of tools they want. DevOps approach, responsible for the build and run of this new offering that they were creating. So this was very much mobile first, mobile focused, and they were quite successful. I think after a couple of months, they were able to release the first version of this mobile app, and they were able to iterate quickly and improve this very quickly. So this was kind of success story. So what happened was they were asked to do the same thing for another market, and the team grew a bit, and that was still okay. They started to have a bit more backend kind of services as well. And that continued to happen, right? So they were because of their success, they were being asked to do more and more with the same team, and they were growing the team. And they got to a point where some of the people in this team, the senior architects, actually felt like, well, we start to have more and more dependencies inside the team. We start to have different work streams inside the team, and which are blocking each other frequently. And so they realized that we're not going in the right direction here. It's becoming slower to deliver. It's becoming we start to have kind of subgroups inside the team where some people only know about certain parts of the system. And so there was some pushback, but eventually they decided to split this into two smaller teams. They did some refactoring and some changes to the architecture to allow this. But what they ended up with was one team that was more focused on kind of the mobile aspects and the products, the product catalog, and another team was more focused on the kind of backend services they had created. And while they were not 100% independent, most of the time they could work on their own backlog. So maybe 80% of the time or 70% of the time. And they know that there is sometimes they need to kind of pair. So that's why those two blue lines in the middle are trying to reference that. But that happens on occasion, but it's not most of the time. So this worked quite well for them. And it's this idea that even if they had started with kind of microservices, at some point they got to a situation where the size and the complexity was growing and was too large for a single team to handle. And so effectively the cognitive load of the team was being exceeded, besides the problems with kind of internal dependencies inside the team. So effectively what they had before was, in a way, they had a large team, but in practice, there were subgroups inside this large team, right? And so by making this more explicit and working on the architecture so they could split the different parts and assign them to the two smaller teams, that helped them, again, be able to go faster and have more, each team have better understanding of the part of the system they were responsible for. So effectively, they were, as the team was growing and the system was becoming quite large, and this was blocking the flow of work across different streams inside the same team. And effectively what they did was listen to this kind of triggers for evolution, where the software is growing too large, and this to some extent is independent of what architectural style we have. It's just that we're having too much to deal with as a single team. You typically start to see some people becoming kind of within the team specializing in some areas, and you see an increase in the need for coordination. So those were the triggers that got them to decide to do that split and into two smaller teams. So if you want to get started with this idea of looking at cognitive load as a key factor in some of the decisions that we make around teams, around system architecture as well, start by making cognitive load more explicit, right? How well do different teams as a unit understand and grok the systems that they're responsible for, that they own and develop, and ideally also are responsible for running in production as well? What are the problems that they have? What are the difficulties that they have in terms of looking at the end-to-end responsibility for this part of the system that they own? I quite like this tweet from Rob Meany, where he's talking about, which effectively is strongly related to cognitive load. What is the engineering experience? How does it feel to build a software, test, release, operate, etc.? And so if some of these things feel very difficult or very painful, first of all, we'll likely not do them very often. So if it's painful to release, we're probably not going to release very often, unless we're tackling that explicitly. And so we can start by just highlighting and effectively asking the teams, what are the things that are causing you difficulties, are causing you pain, that are difficult to do in terms of this end-to-end ownership of your service or your part of the system. And then we can start looking at, are there some things that we can push to this sort of platform? Would there be some useful platform services that would help reduce cognitive load on the stream-aligned teams? Or maybe it's more on the skill set and capabilities that the team is missing, not from any fault of their own, just maybe they don't have as much experience, or they have not been working in some kind of systems that have different architecture or different needs in terms of skills. And so perhaps we could have enabling teams, if we have other experts in the organization that could maybe help us bridge this sort of gaps that we have in skills. So specifically with microservices, what I've seen in some clients that are trying to move from monolith to microservices, they don't often understand, quoting that kind of famous sentence from Martin Fowler around, to do microservices effectively, you need to be this tall, right? You need to have certain understanding and certain skills, and understand that what are the new challenges you're going to have with microservices. And so enabling teams around microservices could be an interesting idea, where if most of our teams are used to work with monolith type of software, if we want to move to a monolith, perhaps we need enabling team. Perhaps we already have some people who are more experienced that can help others understand what are the challenges, what are the new things we need to look at when we're going to be responsible for a microservice instead of part of a monolith. And finally, look at possible misaligned work streams. So if you see that frequently it takes coordination between 3, 4 multiple teams to change a user journey or to implement a given feature, then perhaps the way we identified our streams of work, or we haven't identified the actual streams of work, and so we align microservices to things that are not to some kind of sort of functionalities perhaps, but are not really aligned to the flow of change that the business needs to address. Also, another kind of frequent thing we see in highly regulated or quite regulated industries is that we see development teams that are assumed to understand and know what they need to do in terms of complying with regulations. And so we might actually need some work streams around compliance, for example. So looking at our work streams and trying to identify if we see that we often have kind of these larger projects and it's hard to implement small changes and features in an independent way, then probably we have this misaligned work streams. And finally, start kind of having more intentional interactions between teams, right? So collaboration is good, but it doesn't mean that we should expect every team to collaborate with every team. It's much better if we have specific purpose for different interactions and we know when teams should interact and why. So I talked very briefly, but the three types of interactions that we describe in the book are collaboration, where we're trying to achieve a specific goal. We're trying to solve a specific problem, or we're trying to identify how perhaps a given API should look like, or what kind of needs do we have in terms of monitoring a certain service. Whatever it is, we have a period of collaboration where we're trying to achieve a specific goal. We have X as a service where we're saying, actually, we don't need to interact. The two teams don't need to interact. One team consumes this service that we provide, and we have facilitating where we're helping another team gain some specific knowledge. And so making the interactions more explicit, that we clearly identify what kind of interaction do we need and for how long and what is the purpose, is also quite important for us to be able to address the needs of different teams, help them reduce the cognitive load so that they can focus more of their capacity on the business side. So these three things we can start with when we're trying to think about cognitive load and how do we minimize cognitive load for teams. Again, this is the book, Team Topologies. We're working on a workbook that's going to be available for free, hopefully in the beginning of next year, about team topologies for remote teams. So some specific ways in which team topologies, the ideas in team topologies can help remote teams. There's also a set of trainings that we have available remotely. And if you want to look up the website, teamtopologies.com, we publish new case studies there. Also, there are a number of resources and some videos and other articles around the ideas in team topologies. So if you're unfamiliar, you can start there. And like I said, there's the GitHub repositories under team topologies with the independent service heuristics. There's also an example of team cognitive load assessment and other things that might be useful. You can sign up for news and tips on the website as well. And that's it. I hope this was useful. Me and Matthew are always available on online social media, Twitter or LinkedIn. So feel free to drop us a message if you have any question as well. And that's it.
Excellent. Thanks very much, Manuel. Can I ask if anybody does have any questions, if you would just post them in the chat, and then we'll pick them up from there rather than people trying to jump over each other and ask questions. Manuel, there's one question in there already. Why are microservices mostly called an architecture? Why could you not use one microservice and add others later, independent of need?
I'm not sure I fully understand the question.
I'm not sure I do either.
If So I can tell you, if I understand correctly, and what I've seen, and yes, you are correct. If that's the question, you can move to microservices sort of architecture in a kind of in a phased way, right? So some of the clients that I work with, that's exactly what they try to do, where they have, they start to identify, hopefully using the idea of the value streams and identifying what is the actual stream of work that I can and I should split away from the monolith, so that I can then have one or more teams aligned to this stream of work. And they might do that, and effectively they have at the same time the monolith with everything else that is still kind of bundled together, and they start having a few microservices that run separate from the monolith. So yeah, that works, and is the usual approach I've seen with different clients. I'm not sure if that was the question.
Okay, well, if whoever asked the question is looking for any more clarification, please just sort of expand on that in the chat. Do we have any other questions for Manuel? There's a question. What are your thoughts on trying to minimize knowledge silos by having all teams capable of working across all systems?
That's a quite interesting question. And so what I've seen is that you can have knowledge silos in terms of functional knowledge, right? So those are the kind of the silos that, with DevOps, and we're trying to move away from this idea that, well, only the ops teams know how to run the services, only the dev teams know how to, or they only know how to develop and software. And so when we're talking about functional silos, yes, we want to remove those and have teams that are this sort of build and run teams with end-to-end ownership. In terms of knowledge, business knowledge and system knowledge, I think this is an ideal view of saying, well, what if all teams can work on everything? But in practice, pragmatically, that's quite difficult, right? And so it is important to assign ownership of different parts of the system to different teams, which doesn't mean that we necessarily don't allow different teams to work on the same code, but perhaps that shouldn't be the starting point. We should have quite good clarity on what are the different parts of the system or different microservices, if that's the case, which teams are responsible, which doesn't mean that we cannot have some sort of kind of inner source model or something like that, where you say, well, if other teams need to change my part of the system or our part of the system, they can do that as long as they follow this approach, whatever that is. So there's something we call team APIs in the book, which is effectively exposing to other teams, what is the code that we own, what are the repositories, how do we test, how do we deploy. Those are useful things to expose to other teams, so that if they need to make changes to our part of the system, they do it in a way that is consistent with the team that owns it. So that's what I've seen, where this ideal view that, well, every team should be able to work on any part of the system is quite difficult to have in practice, once you go past, kind of small system size.